Here is a very important and interesting problem. Question 36. Write domain, range, asymptotes, intervals of increase, decrease, turning points, and behavior, and symmetry for the given graph. In a way, you have to write all the characteristics of the given graph. Okay? Remember one thing. When you are looking at a graph, you have to see it from left to right. Okay? It is important since when we say increasing, decreasing, then we see from left to right. If you see from left to right, this is decreasing. Do you see that? And here it is increasing. At times, that is kind of confusion. Another thing is, when you look at the graph, look carefully. Now here you will observe that this point actually, it seems that there is a horizontal asymptote here. So let's draw kind of horizontal asymptote. So it seems that you are approaching this point, correct? But you're not quite there. So this is a horizontal asymptote and this is -1. It seems this point is -half. So let's assume that. This is a graph. We cannot very accurately find the points. Or we can say approximately this point is, we'll call this horizontal asymptote as y equals to -half. Correct? So we are trying to analyze, and here we have a vertical asymptote, correct? And this vertical asymptote is at -3. So we'll say this vertical asymptote is at x equals to -3. Correct? And we are including this point in our domain and range, okay? Now, let's write down all the characteristics of this graph, starting with domain. So what do you think domain is? So let's do domain, and domain, let's say dx is equals to x belongs to real numbers, and x could be, you see from here, it is only less than -4. There's nothing beyond that. So we'll say x is, and it is including, right? So x is less than equals to -4. This is one part. Then we have a vertical asymptote, and the graph really starts after -3 and continues forever. Okay? So, and then we say x is greater than, but it's never equal to. Do you see? Because that is a vertical asymptote. -3. So that becomes our domain, correct? How about the range? Let's say our range is equal to y belongs to real numbers, so that now y is approaching -half. -half is your horizontal asymptote. So y is less than -half, right? Not equal to, correct? And here it is equal to 0 and greater than. Let's make an arrow here, okay? To be very clear. And an arrow here also, okay? Now we say y is greater than and equal to 0, correct? That's the 0, correct? Now this is domain and range. Now asymptotes, as we have given, horizontal asymptote is, that's the horizontal asymptote, because as x approaches plus infinity, our function approaches -half, right? Therefore, horizontal asymptote is y equals to -half. And then we have a vertical asymptote. So a vertical asymptote is x equals to -3. Next is intervals of increasing and decreasing. So let's write increasing intervals. So it increases from, so you see it is decreasing and then increasing. So it is increasing from -3 to infinity, right? You can never include infinity, okay? Decreasing. How about decreasing? From -infinity to where? Correct? -4. So we say -infinity to -4, right? That's the interval of increasing and decreasing. Now turning points. So turning points, do we have any turning points? It really doesn't turn here. It just moves on and on, right? So we say no turning points, okay? No turning points. Nil. Don't write 0 or anything. Just write no. Be specific. 0 not wrong here though. Okay. End behavior. So end behavior means when x approaches -infinity, then what happens to y? So y approaches, you see it's going up. Y approaches positive infinity, correct? When x approaches positive infinity, then y approaches positive infinity, y is approaching minus half, and that is why we have horizontal asymptote. Perfect. Now we have symmetry. Do we have any symmetry here? Nil. There's no symmetry here on the graph, and that's all about it, right? I hope you understand all these characteristics and put them down in a proper order. Okay? Thank you.